This video is going to show you how to solve a complex circuit like the one you see here. The first step to doing this is going to be to find the total resistance. I can use Thevenin's theorem for parallel resistors because these two are in parallel with each other. And if I do that, then that becomes 75 ohms. Now those two resistors are in series with the 175 ohm resistor. So I'm going to add them together now, and I'm going to get 250 ohms of total resistance. Once I've found that, I can move on to step 2. And step 2 is to find the total current. All right, so I'll just write the total resistance up here so we have it. Now the total current, I'm going to have to use Ohm's law. I already have total voltage and total resistance, so I'm going to divide them. Total voltage divided by total resistance. And this becomes 0.04 amps. But customarily I want it in milliamps. So I'm going to move the decimal point 3 places, and that gives me 40 milliamps. Now moving on, step 3 is going to be finding the current through R1. So this is what we have to notice here is the total current is also going to be the current through R1 because the current has nowhere else to split at that point. So my current through R1 is 40 milliamps as well. Now I can move to step 4, finding the voltage through R1. I know the current through R1, and I do know its resistance, so I can use Ohm's law again. V in this case is equal to I times R1. So this is 40 milliamps, but I need to change it back to 0.04 amps because I need base units. So I'm going to multiply that by the resistance of R1, which is 175 ohms. And when I multiply these together, I get 7 volts across R1. So I'm going to write that up here so we have it again for reference. I'm going to move on to step 5. And now I can find the current through each of the other 2 resistors. In order to do this, I have to recognize that R1 is using 7 out of 10 volts. And because these 2 resistors are in parallel, the remaining voltage doesn't divide, but each resistor gets 3 volts. This is because Kirchhoff's rule says that each loop has to have the total voltage used up. So to find the current through each resistor, it's just using Ohm's law again. So for R2, I'm going to divide R2's voltage, 3 volts, divided by R2's resistance, 100 ohms. I'm going to get 0.03 amps, which I'm going to change to 30 milliamps. And then I'm going to do the same thing with R3. So the voltage through R3 is 3 volts, and the resistance through R3 is 300 ohms. And I'm going to get 0.01 amps, or 10 milliamps. All right, so we're almost done. The last step here is I want to find the power. All right, so I'm going to start by finding the total power. And remember that power is equal to the current times the voltage, and we're just going to use this a bunch of times here. So if I want total power, I need total current and total voltage. If I do that, I can't use 40 milliamps again. I need to use 0.04 amps. So I've got to change to base units again. Times the total voltage, which is 4 volts. So I get 0.4 watts, and I can change that to 400 milliwatts. My power through resistor 1 is going to be the current through resistor 1 times resistor 1's voltage. So again, that's 7 volts that resistor gets. That's going to be 0.28 watts, and I change that to 280 milliwatts. I'm going to do the same thing. This is a little repetitive, but just so you can see it. I'll find the power through resistor 2. And remember, resistor 2 got 3 volts. So if I multiply it by the current, it gets 90 milliwatts. And then my last one, R3, also has 3 volts, but a different current. So it has 30 milliwatts. And once I've done that, I'm all done.